Let's explore logical volume management, often called LVM. It's a powerful way to manage disk storage in Linux. We will focus on how to create and manage LVM volumes. LVM provides flexible disk management by combining multiple physical disks into storage pools. You can create logical volumes that are resizable. LVM supports snapshots and migrations. It also enables dynamic storage management. Let's explore the core components of LVM. First, we have physical volumes, abbreviated as PV. Physical volumes are the foundation of LVM. They are regular storage devices like hard drives, partitions, or RAID arrays that have been initialized for LVM use. To initialize a disk as a physical volume, you can use the command create followed by the device path, such as /dev/sdb. To display information about a physical volume, use the command display followed by the device path, like /dev/sdb. Let's continue exploring the core components of LVM. Next, we have logical volumes, abbreviated as LV. Logical volumes are created from volume groups and function as virtual partitions. They can be formatted with a file system and mounted like any standard partition, but with added flexibility for resizing. To create a logical volume, you can use the command create followed by options like N for the name, L for the size, and the volume group to use, such as data_VG. For example, create ndata_lvl10g data_VG. To display information about a logical volume, use the command display followed by the volume group and logical volume name, like data_VG/data_LV. Let's walk through a typical LVM implementation workflow. Step 1. Create physical volumes. This involves initializing physical disks or partitions as physical volumes or PVs. Step 2. Create a volume group. This step combines the previously created PVs into a volume group, or VG. Step 3. Create logical volumes. Now, create logical volumes or LVs from the volume group. Step 4. Format and mount. Format the logical volumes with a file system and mount them to a directory. Step 5. Manage. Now you can resize, snapshot, or migrate the volumes as needed. The key benefits of this workflow include flexible storage allocation without downtime, the ability to span volumes across multiple disks, easy resizing of file systems as needs change, and simplified disk management with logical naming. Let's dive into the process of creating physical volumes. Before creating physical volumes, it is important to identify the available disks using commands like lsblk. This command lists block devices and their mount points. Another option is fdisk_l, then filter with grep for disk/dev/sd. This command displays disk partitions and their sizes. To create physical volumes, use the command create followed by the device path. For example, create /dev/sdb/dev/sdc. This will create physical volumes on /dev/sdb and /dev/sdc. You can verify the physical volumes by using the command pvs, which displays a summary of all physical volumes. Keep in mind that you can also use partitions instead of entire disks by creating partitions with disk or parted first. Now let's explore how to create volume groups. The create command combines physical volumes into a volume group. This creates a storage pool from which logical volumes can be allocated. For example, the command create data_VG/dev/sdb/dev/sdc creates a volume group named data_VG using the physical volumes /dev/sdb and /dev/sdc. You can display volume group information using the VGS command, which shows a summary of all volume groups. Here are a few tips for managing volume groups. Use descriptive names for your volume groups. You can add more physical volumes later with the vgextend command. You can also remove physical volumes with the reduce command, but make sure to move any data off the physical volume first. Let's see how to create logical volumes. Logical volumes are created from volume groups and can be formatted with the file system. They appear as devices under /dev/volume group /logical volume. To create a logical volume, use the command LVM followed by the N option to specify the name and the L option to specify the size, along with the volume group name. For example, create nhome_lvl10g data_vg creates a 10 GB logical volume named home_lv in the data_vg volume group. Similarly, create nvar_lvl5g data_vg creates a 5 GB logical volume named var_lv in the same volume group. The N option specifies the name of the logical volume, and the L option specifies the size with units such as G for gigabytes or M for megabytes. After creating logical volumes, you can format them with a file system and mount them like any other partition. For example, mkfs.ext4/dev/data_vg/home_lv formats the home_lv logical volume with the extension for file system. You can then mount the logical volume using the command mount/dev/data_vg/home_lv/home. Let's learn how to resize logical volumes. To extend a logical volume, use the command lvextend followed by the L option to specify the amount to extend and the path to the logical volume. For example, lvextend L+5g/dev/data_vg/home_lv extends the home_lv logical volume by 5 GB. After extending the logical volume, you need to resize the file system to use the new space. For the extension for file system, use the command resize2fs/dev/data_vg/home_lv. For the XFS file system, use the command xfs_growth/dev/data_v/home_lv. There is also a way to extend and resize in one command. For example, lvextend L+5g, resize of/dev/data_v/home_lv. This command extends the home_lv logical volume by 5 GB and resizes the file system automatically. Reducing a logical volume requires first reducing the file system, then the logical volume itself. For extension for file systems, first unmount the logical volume using the mount/home command. Then check the file system using the command e2fsck f/dev/data_vg/home_lv. Resize the file system to the desired size, for example, 8 GB, using the command resize2fs/dev/data_vg/home_lv 8g. Finally, reduce the logical volume to 8 GB using the command reduce L8g/dev/data_vg/home_lv. Be careful and always back up your data before reducing a logical volume. Reducing the size can lead to data loss if not done carefully. Now let's see how to work with LVM snapshots. LVM snapshots create a point-in-time copy of a logical volume. They're useful for backups, testing changes, or creating consistent copies of active file systems. To create a snapshot, use the command create s_in_home_snap l2g/dev/data_v/home_lv. This command creates a 2 GB snapshot of home_lv. Here's a typical workflow for using snapshots. First, create a snapshot with sufficient space to track the changes. Second, mount the snapshot to access the point-in-time data. Third, perform backup or testing operations on the snapshot. Fourth, remove the snapshot when no longer needed. Snapshots use copy-on-write technology. They only store changes made after the snapshot was created, making them space-efficient. For example, dir/mnt/snapshot creates a mount point. Then mount oro/dev/data_vg/home_snap/mnt/snapshot mounts the snapshot as read-only. Finally, a mount/mnt/snapshot, and then remove /dev/data_vg/home_snap removes the snapshot. Let's cover some LVM best practices and a summary. Best practices include: always leave free space in volume groups for future expansion. Use descriptive names for volume groups and logical volumes that indicate their purpose. Create regular snapshots before making significant changes. Monitor snapshot space usage to prevent them from filling up. Backup LVM metadata with the vgaf backup command. Consider using LVM mirroring for critical data redundancy, and document your LVM configuration for disaster recovery. Here's a quick command reference. Create initializes physical volumes. Create creates volume groups. Create creates logical volumes. PVS, VGS, and LVS display summary information. Display and display detailed information. Extend and reduce resize logical volumes. Extend and reduce add or remove physical volumes from volume groups. LVM provides flexible storage management in Linux systems, allowing administrators to create, resize, and manage storage volumes dynamically without downtime. By abstracting physical storage into logical volumes, LVM simplifies storage administration and enables advanced features like snapshots and mirroring. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.